Hello, welcome back. In this video, we are going to learn about domain name system, which is a part of the application programs of application layer of the internet model. So let's look at the agenda. We will be starting with the concept of domain name system, then the meaning of namespace, after that domain namespace, followed by distribution of namespace, then how the DNS is happening in the internet, after that resolution, then DNS messages. Let us understand the concept of domain name system. In the internet, there are many application programs. Some of the application programs are direct in nature and some are supporting in nature. All these are client-server application programs, meaning there is a client which makes a request and there is a server which gives back the response. Now, direct application programs of client-server types are FTP, HTTP, SMTP, etc. These programs are direct in nature in the sense that the users can directly use these programs. But supporting programs are the ones which make use of some mechanisms and help these direct programs to operate. For example, domain name system is a supporting program. Let's understand the domain name system with the help of this example. Let's say we have a user here and the user wants to access one website. Let's say it is human@abc.com. It is very easy for a user to remember the alphanumeric characters. But these characters must be mapped to an IP address. Because at the application layer, you can have these names, but when it goes to the transport layer, it has to use the IP address at the network layer. From the transport layer, it has to go to the network layer with a given IP address. Now, how to get this IP address is what DNS is all about. So the user knows this name human@abc.com. It sends it to the SMTP client, which is the email. This SMTP client sends this message to the DNS client. DNS stands for Domain Name System and SMTP stands for Simple Mail Transfer Protocol. This DNS client will send this information to the server. Now, there is a mapping of names with IP address. So, the DNS server will look into the names and map it to the IP address. So, it will get back the IP address. Suppose it is 200.200.62.5. So this is the IP address corresponding to this website. So it will send it back to the client and the client will send it to SMTP client. So this will be 200.200.62.5. So now this IP address can now be sent to the transport layer, from there to the network layer to be sent to the other server. So this is the concept of DNS, meaning mapping of names to the IP address. Let's understand the namespace. In order we choose the names from the namespace, we must carefully choose the names because they must be unique in nature. Why? Because these names are mapped to IP addresses which are unique in nature. So that's why these names must be properly chosen. Now this namespace can be divided into two parts. One is called the flat namespace and the other one is a hierarchical namespace. For a flat namespace, it is very simple. It consists of few characters. And this is only possible in case of smaller system. Because if the system becomes very much larger, like the internet, then maintaining the names by a central authority becomes very difficult. So if the system is small, you have a smaller number of names, so it is possible to use the flat system of namespace. But for a larger system, we go for hierarchical namespace. This hierarchical structure actually consists of several levels. It is divided, the names are divided into several parts, and each part is separated by a dot. So we will learn more about it. So this is the overall concept of namespace. Let us now understand domain namespace. What is the concept of domain namespace? Now the domain means a website. So here you see here the domain namespace is divided into several levels. So these are all the levels. This is one level, this is one level, this is another level. Like this, it goes up to this level, and this level is known as the root level. So it is in the form of an inverted tree. There can be 128 levels. So starting from the root, so we have 0 to 127 number of levels. For example, after the root level, we can have like this ARPA. This is one level. We can have COM. We can have edu. We can have org. We can have add. We can have ZW, like this. Basically, these levels define different subcategories like the organization, then department, country, etc. So we started like this. Let's say the lowermost level is XYZ. Then we have the DEF, after that ABCD, then we have the edu, and this is the final root. So at each level we can have the domain name like this. So this will be xyz.def.abcd.edu. So this is one domain name. At this level we can have this domain name as def.abcd.edu. This dot is important because dot means it goes up to the root level and dot has a null string. So this is again a domain name. At this level we can have the domain name as abcd.edu. At this level we have edu. So like this, the domain names can be written in the form of levels. Now we can have fully qualified domain name. So this is an example of fully qualified domain name. We can have partially qualified domain name. Here if we just simply write XYZ, then it is an example of partially qualified domain name. So this is the example of domain. How is the distribution of namespace done? We have the root server at the root. From the root server, we can have several servers at this level, like we can have ARPA server, we can have edu server, com server, and the in server. Again, from this edu server, we can have two child nodes, like, so it will be named as abcd.edu.xyz.edu. So these two are under com server, so it will be named as efgh.com. And this will be uvw.com. So this is the hierarchy of name servers. So from the root server, we can have, we can have, let's say we are taking this com. So this is we can have the com server. From the com server, again, we can have several child nodes. Let's talk about this child node. This child node has again another node in the next level. So from this level, again, it has forked into several child nodes. So this way, we can segregate the entire levels into domains. So this is the domain under root of com. Now, this com is a zone again. Zone actually has a zone file which keeps the mapping of all the names and their corresponding IP addresses. If the domain is not further subdivided into subdomains, then the concept of zone and domain remains the same. Now here you can see that this is a domain as well as a zone. So this is the concept of zone and domain. We can have different types of servers, like we can have root server, primary server, and secondary server. The root server, as we can see here, it is a main server and it is the authority of all the domains under its control. So it is known as a root server, but it gives its control over to all other servers and just keeps a copy of the references of the servers immediately under its control. Then we have the primary server. Primary server is the one which actually keeps the information about all other servers under its control. We have the secondary server. The secondary server is a duplication, or we can call it a redundant server in case the primary server fails. So the work of the secondary server is to pass on the information from other servers to the primary server, but it has no authoritative control to manage the other servers. How is the DNS in the internet? So we have the root, and there are basically three domains. One is the inverse domain, generic domain, and country domain. The inverse domain basically maps the IP address to the domain name. The generic domain is a general name given to all other domains, and the country domain, as you can understand from the name, it is the country part of the particular URL. So here let's look at the different levels we can have. We can have aero level, which is basically the airlines. We can have biz for business. We can have com for commercial purpose, co-op for cooperative, society, edu for educational purpose, gov for governmental purpose, info for information related purpose, int for international organizations, mil for military, museum for museum, name is the personal namespace, net is the network support, org is the non-profit organizations. Pro is the professional organizations. Then we come to the term resolution. Resolution is basically the one where we have a resolver which uses the name address resolution. Like this is the mapping of name with the address. Either mapping names to the addresses or mapping addresses to the names. This is done by the resolver. How many types of resolutions are there? We can have recursive type of resolution, iterative type of resolution, and cache type of resolution. For recursive type of resolution, if there is a client which wants to know the IP address of a particular domain name, it sends it to the server. Then the server sends it to the corresponding servers. If this server is the ultimate server, then it will send back the address name. If it is not, then it will send it to the corresponding server till the root server is reached, from the root server again to all other servers, and ultimately if it reaches the desired server, from this server again the response will be fed back to the root server, from the root server to these intermediate servers, and finally this server will be able to give back the IP address of the name that the client has asked for. So this is known as a recursive type of resolution. What is iterative type of resolution? In iterative type of resolution, if the client requests the server for IP address of a domain name and the server, if it does not have it, it will send back the name of the server. Actually, it will send back the name of the required server instead of transferring the message to the required server. So once the name of the server is reached at the client side, that the client will directly send it to the required server, and the required server will send its response back to the client. So this is known as an iterative type of resolution. Cache type of resolution means many a times the servers get requests from the clients, and instead of throwing away the requests, it stores them in a file, in a cache file. Later on, if the same client makes a request, then the server looks into the cache memory, and if it finds out the desired result, it can give it back to the client. So it can save a lot of time and space. Let's now talk about DNS messages. DNS messages are of two types. One is the query type of message and the other one is the response type of message. The query type of message will consist of the header and the question record. The response type of message will consist of the header, question record, answer record, authoritative record, and some additional records. What are the types of records? The types of records are question type of record, which is normally done from the client end. The client sends the query type to the server, so this is the question type of record. And the resource type of record, which is normally sent by the server as response back to the client. Now, there are certain registers where this mapping of the domain names and the IP addresses are kept. So this is a website where you will get the registers, http www.internic.net. It will have the domain names and their corresponding IP addresses. To summarize, in this video, we have learned about the concept of domain name system. We learned what namespace is all about. We learned how unique the namespace must be as it is mapped to the IP address, where IP address is also unique in nature. Then we understood about the domain namespace, how the distribution of namespace is done with the help of domains and zones. Then the DNS in the internet, how the resolution is done, the different types of resolutions like iterative type of resolution, recursive type of resolution, and cache type of resolution. And we understood about the different types of DNS messages like query and response. Thank you.